Hello, hello. My name is Amir Soni. I'm from batch 38 and I'm currently enrolled in my full stack web development course. And our project title is Travel Recommendation System. And I would like to ask the first question to Soumya. What is the scope of the project and why do you choose the same?
Hi, I'm Soumya Marishetti. I belong to batch 38 and my student ID is FT38413. And the scope of our project is to create personalized travel recommendation platform that assists users in discovering travel destinations based on their preferences. It includes functionalities like a user preference survey, personalized suggestions, an interactive map, and the ability to view and compare. The platform will feature reviews and ratings, dynamic things, trending destinations, and a seamless mobile experience. With my interest in front end and back end and web development, uh, building a platform that integrates various elements like location data, user preferences, and dynamic suggestions allowed me to explore multiple multiple things of web development while addressing a real world need in travel domain. And I wanted to ask a question to Sarvam. Can you walk me through the most challenging technical problem you encountered in your project and how you resolved it?
Hi, my name is Sarvam. Uh, I'm student of batch FT36 and my student code is FT36 underscore 232. Uh, One of the most challenging problem I faced was with the destination magic matching logic for the recommendation engine. The initial implementation was not returning the correct result because of the matching process for the user preferences, such as budget, destination type, and city, was not robust enough. For instance, when filtering cities based on user preferences, the code didn't account for scenario where a user did not select a specific city but still wanted suggestions for any city within the selected country. This was a critical issue as it led to user not getting relevant recommendation. We resolved this by refactoring the matching logic to ensure that it would handle empty or null values in user preferences gracefully. For setting batching, I allowed the city field to be optional. So if the user did not specify a city, all cities within the selected country would be considered. I also ensured that other conditions such as budget and destination type were consistently checked and introduced more detailed error handling and logging for better debugging. So my next question for Amia is, what specific technologies did you use and why did you choose them for this project?
For the front end, we used React because it allows us to build dynamic, responsive, and interactive user interfaces using a component-based architecture. It also integrates well with integrate well with the other tools and libraries we needed, such as React Render for navigation. React Router for navigation. Bootstrap was chosen for its pre-built responsive grid system which sped up the design and ensured that the platform looks good on mobile devices. I used HTML and CSS for structuring and styling the content. On the backend, we use Node.js and Express due to their non-blocking asynchronous nature, which is ideal for handling multiple simulations requests efficiently. This also allowed us to build a RESTful API to handle communication between the front end and the backend. MongoDB was MongoDB was selected for its flexible document-oriented structure, which made it easy to store dynamic user preference data. We also use JWT for secure authentication ensuring that users could safely log in and access their personalized information. Node Mailer was integrated for email services, providing users with confirmation when they submit preferences or make changes to their profiles. I would like to proceed with the next question, and I would like this question to be answered by Soumya. Did you encounter any performance issues? How do you identify and address them?
Yes. When querying and filtering large datasets for destination suggestions, we encountered performance slowdowns. For example, fetching the user preferences and matching them against all available destinations took longer than expected. I identified this issue through logging response times for different operations in the backend. The problem stemmed from performing filtering and matching operations synchronously, which caused the server to lag. When handling multiple requests at once, to address this, I optimized the code by making the filtering process asynchronously. I implemented pagination and caching where applicable to reduce the load on database. Additionally, I ensured that the front end only made API requests when necessary, avoiding unnecessary refetching of data. We also leveraged indexing in MongoDB to speed up queries for frequently asked fields like city names and destination types. And I want to ask the next question to Amia Soni. Can you explain the architecture of your project? Why was it designed this way?
The architecture follows a client-server model with a RESTful approach to handle communication between the front end and the back end. With the front end is built with React, allowing us to build dynamic and interactive UI components. The back end is powered by Node.js and Express, which serves the front end through APIs. The MongoDB database stores user preferences and recommendation data. The design is modular to promote maintainability and scalability. The separation between front end and back end allows for independent development and scaling of both components, making it easier to add features like advanced filtering algorithms or new UI components without affecting other parts of the system. The recommendation engine is housed in the backend, which ensures that data manipulation, filtering, and heavy logic are kept away from the front end, improving performance and the overall security. I would like to ask the next question to Sarvam. How did you ensure the scalability and security of your project?
To ensure scalability, we followed best practices in both code structure and system design. For example, the backend API was built to handle a high volume of requests asynchronously using Node and Express, which were well suited for scalable application. We also implemented caching for frequently requested data, which reduces the load on server and speed up response time. Security was a key concern, especially since the platform stores sensitive user data. We use JWT for secure authentication, ensuring that only authorized user can access and modify their preference. Passwords were hashed using bcrypt to ensure that even if the database is compromised, the password remains safe. We also followed the principle of least privilege, ensuring that user only had access to data they were authorized to see. Additionally, we sanitized user input to protect against SQL injection, XSS attack, and other common security vulnerabilities. That's all from our end. Thank you.